Today I'm going to cover the laws of exponents. One law states that if you have a to the power of n times a to the power of m, we can conclude that we get a to the power of n plus m. Why is this so? Let's look at an example. Let's say we have 2 to the power of 3 times 2 to the power of, say, 2. Okay, now as long as we have the same base, the laws of exponents say we can add the exponents together. But let's prove it. What's 2 to the power of 3? Well, 2 to the power of 3 is really 2 times 2 times 2. And 2 to the power of 2 is 2 times 2. And we're multiplying together. You see that there are 1, 2, 3, 4, 5. So therefore, that gives us 2 to the power of 3 plus 2, which gives us 2 to the power of 5. So let's look at this problem. Simplify a squared times a to the power of 4. So we can write it as a squared times a to the power of 4 equals, since they're both the same base and they're separated by the a, we can say that a to the power of 2 plus 4, which equals a to the power of 6. And that's your solution. What I've shown you is called product of powers property. The next thing I'm going to show is called the quotient of powers property. As you can guess, that's dealing with dividing when earlier we were dealing with multiplying. This property basically states that if you have a to the power of n divided by a to the power of m, notice they're both the same base of a, then you can say that you get a to the power of n minus m. Let's go back to a specific example. Let's say we have 2 to the power of 5 divided by 2 to the power of 3. What does that mean? Well, 2 to the power of 5 means we have 2 times 2 times 2 times 2 times 2, 5 times. And 2 to the power of 3 means 2 times 2 times 2, 3 times. Now when we cancel, we can cancel the top and the bottom, top and the bottom, top and the bottom. That leaves us with what? 2 times 2. 2 times 2, which is the same as 2 squared. And that simplifies to 2 squared equals 4. That's your final solution. Let's do another simple example for quotient of powers property. So let's say we have 3 to the power of 9 over 3 to the power of 6. So that gives me 3 to the power of 9 minus 6, which simplifies to 3 to the power of 3, which simplifies to 27, because 3 times 3 times 3 gives us 27. We also have the zero exponent, which states that for any a that's not 0, if it is to the power of 0, it equals 1. I proved that in another video, links down below. Note that 0 to the power of 0 is undefined. So if we have 2 to the power of 0, that equals 1. We can substitute any number in here. We can say 125 to the power of 0 equals 1. Now that said, if you have a question that wants you to simplify, say, an expression that has something like a to the power of 5 over e to the power of 0, given b is not equal to 0, what's your answer? You can say that a to the power of 5 remains as a to the power of 5, but b to the power of 0 is 1, so your final answer is a to the power of 5. Negative exponents state that as long as a is not equal to 0, a to the power of negative n is equal to the reciprocal of a to the power of n. Again, I explain that or prove that in my other video, link down below. So if I have 5 to the negative 2, I can say that that equal to 1 over 5 squared, which is equal to 1 over 25. We always want to try to simplify our exponents to a whole number where possible. Conversely, if I have, say, 1 over 3 to the negative 2, that can be written as, we're going to take the reciprocals, so we're going to write it as 3 squared. It now becomes a positive exponent over 1, and that simplifies to 3 squared, which gives me 9. It doesn't change if we have variables, so if we have, say, x to the negative 3 over 4 to the negative 1 times a, we want to have positive exponents. So I'm going to take the reciprocals of the bases that have negative exponents. So that would be the 4 and the x, and I'm going to switch places for them. So our 4 now goes to the numerator, and that gives a positive 1 over my x goes in the denominator, and it becomes a positive 3 in the exponent. And because our a has a positive exponent, that remains in the denominator. So that simplify. 4 to the power of 1 is 4 over x cubed times a. Finally, we have a power of a power property, which states that a to the power of n to the power of m gives you a to the power of n times m. Now, don't be confused with our product powers of property. This one is where you have the exponents separated by your parentheses, and earlier on in the product powers property, your exponents were separated by a base. So, as a simple example, let's say we have 2 squared to the power of 3. I can write it as 2 times 2, which is the 2 squared, to the power of 3. That means I have it 3 times. Squared and 2 squared. Because it's a cube, so I have it 3 times. So how many 2's do we have? 1, 2, 3, 4, 5, 6. So therefore, that gives me 2 to the power of 6, which is the same as 2 times 3, which gives us 6. What about something a tad more tricky? Let's do x to the negative power of 2 to the negative power of 3. Remember, this is the exponents are separated by the parentheses, so all we have to do is multiply the two exponents together. Now, a negative number times a negative number gives you a positive number. You can review my overview of negative numbers in another video, links down below. So we get x negative 2 times negative 3. And what does that give us? That gives us x to the power of a positive 6. That's our solution. Now, if you notice, all the previous laws that we've covered all only covered exponents with the same base. In this case, all of them had a's as the base. Now, the power of a product property, however, includes 2 bases or more. So in this case, a times b to the power of m is equal to a to the power of m times b to the power of m. The exponent is distributed amongst the 2 bases. Why is this so? Let's say we have 2 times 3 to the power of 2. That means we have 2 times 3 times itself again, which is 2 times 3. Now we have 2 2's, so that gives me 2 squared, and 2 3's, which gives me 3 squared, which is the same as our power of product of property as shown. Okay, let's do an example. Let's say we have negative 2y cubed to the power of 2. So Remember, our exponent on the outside is distributed among each of the terms on the inside. So we're left with negative 2 squared times y cubed squared. Now, if you notice, I put parentheses around each of my terms. This is very important, especially when you have negative terms and you have a positive exponent, because the negatives will become positive. So that gives me negative 2 times negative 2 gives me a positive 4. And y cubed to the power of 2 gives me y to the power of 6, because 3 times 2 equals 6. And that's your final answer. As you probably guessed, what applies for the multiplication also applies for the division. So this is what we call the power of quotient property, where a over b to the power of m is equal a to the power of m over b to the power of m. So let's say we have x over negative 10 to the power of 3. The power of quotient property says that we can say that we have equivalent of x to the power of 3 over negative 10 to the power of 3. If you notice again, I have my parentheses around each of the bases, so we keep track of our negatives in there while we do our exponents. So that equals x cubed over, now it's an odd number of negatives, so we still retain that negative. 10 to the power of 3 is 1000. That's how we solve that. So let's try this example. When we evaluate expressions like this, we always want to get rid of our negative in the exponent. This would be equal to, in order for us to get rid of that negative 1 in the exponent, we have to take the reciprocal. Becomes 1, 8. And remember, 9 to the power of 0 is 1. Now notice that there is no parentheses around that exponent of 0. So the negative remains. So we're left with negative 1, 8. This would be different from a question where we have negative to the power of 8 to the negative 1 over parentheses negative 9 to the power of 0. In this case, your negative 9 to the power of 0 becomes 1. We have that 8 to the negative 1 in the numerator, which we want to bring to the denominator. And as you can see, there is a difference in answers. One is a negative and one isn't, because the parentheses changed your values. How about another question? So let's look at this. We're always going to look out for the exponents with a 0, because that gives us a 1. I'm going to change my 3 to the power of 0 to become 1 s squared. My r is to the power of negative 1, so I'm going to put it in my denominator as so. Now I've left my s squared in the numerator and my 2 squared in the denominator, because those have positive exponents. So let's simplify. I'm not going to write my 1 this time because that's presumed. And 2 squared is 4. R to the power of 1 is simply r. And that's my final solution. Let's try negative 5 times negative 5 squared. This one's a little tricky, so I'm going to rewrite it as negative 5 to the power of 1 times negative 5 squared. Now, do you see that it matches the product of powers property, which has my negative 5 as the base? I have the same negative 5 as the base, and therefore I can add my exponents together. And that gives me negative 5 to the power of 1 plus 2, which gives me negative 5 to the power of 3. Now notice I keep my parentheses in all of them so that we can keep track of our negative sign. In this case, it's an odd exponent, so my negative stays in the answer. And we have 5 cubed, which is 125. And that's our final answer. Let's try one final question, this time with a quotient and a negative 2 as an external exponent. So now it's a negative 2. We want to get rid of that. So I am actually going to reciprocate my fraction to get rid of that negative on the outside. That leaves me with a positive. And then I can distribute my exponent in each of my terms on the inside of the exponent. So I'm left with x square over 6 square, which gives me x square over 36, because 6 times 6 is 36. If you like this video, please be sure to like and subscribe to my channel. I offer tutoring services online, and I also offer lessons worksheets including full answer keys available online as well for sale. Links down below. If you'd like to support my work, I have a Patreon account. Links are also down below. Thank you for watching, and I hope this lesson helped you.